Hi everyone, in this video we will use a Shiny item analysis to conduct item and test analysis based on classical test theory. We will use a pseudo data set with 600 people and 32 items. All the items are binary, or in other words they are dichotomous. So we will just get ones and zeros in the data set. You will find the link to the data file in the description part in this video. So now let's just go ahead and import our data set to get started with our analysis. I will open the data tab. And as you can see, there are some training data sets here, but the data set that we are going to use, again, it's a CSV file, or in other words, it's a comma separated values file. So all the values are separated by commas, basically. So it has a .csv extension. We will click on browse. So it will go to the file or just wherever you kept the file. This time I put it on my desktop. So once the data upload is complete, you will see this bar, and at the bottom it says what type of data set are you uploading. So it's a binary data set, and the file is separated by comma, so I will keep it like this. And there's no quotations, we don't have to worry about this section. The data specification, I have the first row indicating the item or item or question names in this case. So I will keep it as it is, checked. And I will keep the item names as they are. I don't want to rename my items. So in my data set, since this is kind of like a pseudo data set, there's no missing values. But if I had one, and if I wanted to keep those missing values, I could just check this option. But now I will just skip this. So we will just scroll down to see like if there's anything else. Basically you can upload if there's any grouping variable or criterion variable, or if you have any observed scores. But in this case, the only data set that we have is the response data set with all those ones and zeros. So I will click on this upload data button. It will upload the data. Now it says your data were successfully uploaded. So we will go back to data exploration tab to confirm that everything is good to go. So right now it says main data set. I will scroll all the way to the right. As you can see, I can see all of my items, item 1 all the way to item 32. And there are no answer keys or correct answers for my items because this is already a score data set with ones and zeros. And as you can see, the scored or binarized data is still the same type of data, and there's no other information relevant to our analysis at this point. All I want to know is that data has been imported properly. It is the case, so I can move on. So this time, what I'm going to do is that, first of all, I will just click on this Shiny item analysis under this Shiny item analysis app, and I will click on this traditional item analysis. I will click on this one. So it says the difficulty is based on average scale scored. You can leave it as it is. Here you will see 3 different item discrimination values. The RIT value is the correlation between the item and total score, which is a very common discrimination index. The RIR value indicates the correlation between an item and the total score on the rest of the items. Basically, it excludes the item that we are interested in as the system calculates the total score, and it correlates the total score with the item scores for each individual item. So either just RIT or IRI are, so those are common indices. So there's also a third index here called like ULI, so based on the upper and lower index. So I'm not going to use that one. I will go with the most common option, which is also the default option, which is RIT. It is the correlation between each item and the total score. So as you can see, we can set up a threshold here. Remember, typically in classical test theory, we say that the threshold for item discrimination should be around 0.2. Any item with less than 0.2 discrimination should be potentially flagged because item doesn't discriminate high and low achieving examinees or individuals sufficiently in that case. So you can either just keep it as it is, or just you can increase the threshold. Typically, it is 0.2, but if you don't like the threshold, you can literally just get rid of it, and the horizontal line will be gone. But I'll just keep it as it is. So as you can see, I have the plots based on the items that I uploaded. So all the red bars indicate the difficulty parameters for the individual items, and the difficulty is the proportion correct in that case. In other words, how many people answer the item correctly. So as the bars get higher and higher, so they become easier. Otherwise they are just getting harder. So, and also as you can see with the purple or bluish type of bars, we are seeing the discrimination values for each item. And as you can see, some of the items such as item 9 and maybe item 12, and item 12 here and item 21, so item 11, so they have a little bit, they have some discrimination values lower than 0.2. So possibly we should just go ahead and take a look at those items closely after this item analysis to find out what's going on with those items. If you want to just download this figure, you can click on this download figure. It will download the figure to your computer, and we will scroll down to see the rest of the item analysis. So here you are seeing a typical item analysis table. So DIFF value indicates the difficulty values. Again, these are kind of average item scores divided by its range, or in other words, basically like how many people answer the item correctly, since it is a binary item. Average score is going to be the same thing as the difficulty in that case. Standard deviation, minimum maximum values for each item. So we see that minimum is 0, maximum is 1. Again, it's not surprising because we are dealing with binary data set. So we are also seeing this ULI, RIT, RIR values for our items. For each item, you will just get this 3 reliability index, 3 item discrimination indices. And finally, we had this REL, shortly, or item reliability index. So that also shows the reliability contribution of each items to the reliability. So another one that I just want to highlight here, another important column is going to be alpha drop. So it indicates how the coefficient alpha value, which is the internal consistency of the exam, will change depending on the item. So each value that we are seeing here indicates what's going to happen to the coefficient alpha value or reliability if we get rid of that item. For example, right now we are seeing that it is 0.8, so it seems that removing item 2 would lower the reliability to 0.79. It goes like this. So right now I cannot comment too much on it because I don't know the reliability of the exam at this point. So I will also just show you this. But the table is really useful to understand the overall difficulty of the items, the discrimination, and how the coefficient alpha will just change. And also, as you can see on the right hand side, it also shows how many people missed the item, if there are some not reached items, like people who never just saw the item. So we could also see the percentages. But like I said, this data set is a pseudo data set. So that's why there's no missingness in it. So that's why all the percentages are 0 in that case. And if you also want to download this value for the entire test, you can click on this download table. And at the bottom of our test, you can see that it says the estimate of Chromebox alpha, or coefficient alpha actually, for the entire test is around 0.8. So now we know what the reliability is for the entire test. So basically, we can compare how the reliability just changes depending on keeping or removing the item. So for example, going back to item 12, it seems that removing item 12 will bump up the reliability value a little bit on this case. So this is not necessarily a good sign because getting rid of the item makes your test better. So obviously that's a negative signal about this item. And if you take a look at the discrimination values, doesn't matter which one you are looking at, but let's say that we are looking at the item RIT value or RIR values. So as you can see, the discrimination values are all very low. So the item is not discriminating very well, so it is not surprising that getting rid of this particular item will bump up the reliability values in that case. So even though the table, again, the bottom note tells us what the reliability is, I will still go ahead and I will just show you how to calculate the reliability values based on this particular data set. We will go back to the reliability tab. As you can see, there are multiple reliability indices here. The one that I want to know is Chromebox alpha, or just more correctly is coefficient alpha. It indicates the reliability or internal consistency of your exam. The number will go between 0 and 1. The higher the values, the more reliable your test is. As soon as you click on reliability, as you can see, we just get the reliability estimate right away. It is, in this case, 0.802. So I'll just highlight it over here. So this is good because the reliability has been already calculated, or internal consistency, and the values right next to it, they indicate the 95% confidence interval around the coefficient alpha in that case. So based on these two values, I can just say that I am 95% confident that the reliability of our exam or test or instrument more generally goes between 0.779 and 0.824. So in that case, we are giving a range around the reliability rather than giving a single reliability value. But in this case, 0.802 also is not necessarily bad. So is it good for high stakes exams? Not necessarily. So I would expect the reliability to be at least like 0.9, even like closer to 0.95. 0.8 right now is not bad. So possibly if this is an exam being used for grading purposes, I think in that case it is good to go. So it could be used. However, if you are using this test to make some important decisions, like some kind of pass-fail decisions, high stakes decisions, in that case, 0.802 may not be that sufficient. So based on these two analyses, now we know how to calculate item analysis values, like all those like difficulty, discrimination, and other indices, and we learned how to calculate reliability. We can also check the total score. So I can just go ahead and just see how the total scores can be calculated based on my data set. So as soon as you just click on this part, it will just show you that you have 600 people, just like I said earlier. It already summed up all the values. It says the minimum score on the exam is 4, the maximum score is around 32, the average is around 18.48, and we have the median around 18. Standard deviation is 5. We have the skewness and kurtosis values indicating this distribution. So in this case, I don't necessarily have a cut score to identify any groups like higher or lower groups or anything like that. But you can just literally just move it up or just down to create a flag around your distribution to see like how the score values are really changing. And as you can see, as I'm just moving my mouse around the bars on the histogram, so you can see different scores, score levels. For example, this is like score of 25, and you can see how many people obtained this score. I have 17 students or examinees who got 25 on this test, and the proportion of these people is roughly 0.028. So it applies to everybody. So as you can see, by looking at each bar, you can see different score levels and how many people obtain those scores. So the height of those bars will indicate how many students just or examinees just got that score. So just like the other figures, you can also just click on download figure, and you should be able to download the entire histogram to your computer and use it in your paper or in technical report. So this is it for now. So again, the last thing that I will just mention, but I'm not going to demonstrate, is going to be the reports tab. So if you want to just get a report summarizing all the analysis that we just did in a detailed way, you can click on the reports tab and you can get an HTML type of report based on the analysis that you are running, or you can get a PDF type of report, but it requires the LaTeX program to be installed in your computer already. So if you don't have LaTeX in your computer, ignore it, get the HTML. Otherwise, you can get all the results as a PDF document. So either way, you will get really nice results or reports summarizing all the analysis that you conducted. So this is it for now. In the next video, I will demonstrate how to run IRT models using binary data under ShinyItemAnalysis.